Our first speaker this evening is Dr. Philip Stoddard, Professor of Biological Sciences at Florida International University, and he's going to speak on two topics, so he gets 20 minutes. Health risks from power lines and Turkey Point's troubled history. Dr. Stoddard.
Thank you very much, and thank you all for coming out on a Thursday night. And I also wanted to recognize Commissioner Beasley, who has been of great assistance, and our liaison with FPNL on the power line issue. I got interested in this business about the same time and about the same reason all of you did. I read in the newspaper we were going to get high voltage power lines through our neighborhood. But one thing I've got that you guys haven't got is access unpaid to the biomedical literature, because I work at FIU. And I've got research skills, and I began doing some reading in the biomedical literature. And the more I read, the more disturbed I became. And I began asking deeper questions, like why are we in the situation in the first place? And I wasn't happy with what I read about that either. And so that's what I'm going to present to you this evening. And I've spent hundreds and hundreds of hours, as my wife will attest, staying up late at night, going through the biomedical literature, going through the Miami Herald archives, and going through the filings of the Nuclear Regulatory Commission to see what are the issues, making my best sense of the science, accepting some of it, rejecting some of it, questioning all of it. And I'm going to try to share that with you tonight in a fairly digestible form. So if you go to the website of the National Cancer Institute of the NIH, you'll find a page that looks kind of like this. And they talk about electric fields and so forth, and they conclude by saying, overall, there's limited evidence that magnetic fields cause childhood leukemia. And you can read that two ways. You can say there's not much evidence, it's limited, or you can say the NIH is admitting that there is some evidence that magnetic fields cause childhood leukemia. Read it either way. Now, if you read more carefully, you discover the most recent paper they cited in that website is from 2000. And there's been a lot of stuff published since 2000 on this field. It's a hot field. And these are a couple of studies, one published by Draper in 2005, another by Lowenthal and his colleagues, 2007. And what they did was a case-controlled study of exposure to power lines. That is to say, how far do people live from power lines? And they matched those people up with people who live far away. And what they find is that the closer you live to a power line, the greater your chance of getting leukemia. And that risk is highest for children. And it's highest. You see it's higher on the upper line than the lower line. That's a more sedentary population. They move around less, and so they're more likely, if they live in a house near a power line, to be living in that house for the whole time. These are not happy numbers. So we've heard Florida Power and Light representatives and Mike Halpin of the Department of Environmental Protection in Florida telling us that Florida has standards, exposure standards on the edge of a power transmission line, right of way. The maximum limit in magnetic field exposure is 15 microteslas. And they say, you know, you're lucky you live in Florida because we're one of the few states that has a standard. Well, the typical maximum limit allowed internationally is 100 microteslas. That's the U.S. standard, that's the European standard. The World Health Organization says the maximum chronic level is 100,000. Sorry, 100 microteslas. So 15 may seem conservative. But the typical household exposure is 9/100ths of a microtesla. And so you might ask, okay, so what's the magnetic exposure that corresponds to an increased risk of leukemia? And that's 1/3 of a microtesla. Being exposed to 1/3 of a microtesla chronically is associated with a doubling in the risk of leukemia, particularly in children. And so the allowable risks, the allowable limits, are many, many times higher. And these are my sources here. Everything I'm going to show you today is from published sources, peer-reviewed literature, stuff that I can back up. And I can give anybody the publication citations, or I can even get you the publications if you want to see it for yourself. So these are the things we worry about for our children. You know, you tell your kids, you know, don't accept rides from strangers. Some people say don't go out of the house. You know, look both ways crossing the street. So the risk of homicide of our children is about 1 in 80,000. Risk of kidnap is roughly 1 in 7,000. risk of an auto fatality is 1 in 4,400. What's the risk of leukemia for our kids? 1 in 1,600. Now, what if you lived right where you're sitting at this very moment? Right in this room. What number of kids would be getting leukemia? 1 in 800 sitting in this room. If you lived where you're sitting right now, that would be your risk. Statistical risk. And so when I say near power lines, what am I talking about? My good neighbor Christopher always says, Philip, don't use vague terms with me. So near is defined as between 0 and 50 meters, or in the English system, that's 0 and 164 feet. Some studies measure distance. That's using what's called wire codes. Other studies are taking averages of exposure. Instantaneous measurements aren't very useful because magnetic fields fluctuate with power demands. Between 0.3 and 0.4 of a microtesla is what the different studies seem to show is associated with a doubling in leukemia risk. So one of the criticisms that is frequently leveled of the epidemiological data is that there's no good animal models. And I've heard this from all over the place. And I sort of accepted it. I figured these guys knew what they were talking about until I went and started looking in literature myself. And I discovered people have been working really hard on animal models. And you can argue about what makes a good animal model and what doesn't. But let me give you what I think is the best of the animal studies here. And what these guys do is they take a strain of rats, lab rats, and they expose them to a chemical, a carcinogen that causes cancer. And they twiddle with the dose over many, many studies until they can give about half the rats cancer. Then they say, okay, our rats are getting cancer. What happens if you do this to them or that to them? Does that change the risk of cancer? When they expose these rats to 100 microteslas, which is the amount allowable under US law, European law, and recommended as a maximum by the World Health Organization, they see a 45% increase in the cancer. So we're all exposed to carcinogens every day of our life. You know, from the air we breathe, to the water we drink, to the food we eat. And the last thing we want is something that's going to increase our cancer rate above background. But that's what happens to rats when they're exposed to magnetic fields at 100 microteslas. And how long does it take? Well, I showed you a data point here at 21 weeks. That's not very long. That's less than half a year. So half a year's exposure will do it. So we took these numbers, and my wife Gray and I sat down with Google Earth, and we figured out how far are things in South Miami from these proposed power lines. And we weren't happy with what we saw. So what you're seeing here is the leukemia belt. And so the orange band up there is centered around the power lines. That's the highest risk zone. And I should note that the zones aren't delineated in nature. They drop off with roughly the square of distance. But you can see that South Miami Hospital is in the zone, City Hall's in the zone, that's where you're right now. The metro station, Sunset Place is on the edge of it. Red Road Commons is on the edge of it. Red Road Commons is our highest residential density, something we complain about around here. So look at this, Manor Lane Apartments, between 2 and 2.5. Now what's the hazard ratio? This is critical you understand this. So a hazard ratio of 1, that's your background level. Whatever the population has, that's represented by 1. So 0.5 is half the population risk, 1.5 is half again more, 2 is twice the population risk. So Manor Lane Apartments between 2 and 2.5 times the background risk of leukemia. Where you're sitting now is that red square, about 2 times. The library is about 2 times, including the children's section. South Miami Hospital. You go to the hospital to get well, right? Look where South Miami Hospital is sitting, between about 1.7 and about 2.3. Shops at Sunset. I don't think I'd want to take a job there. And hey, Vinac, you wanted to hang out at Shops at Sunset? They put the power lines in it, forget it. You're not going there. Enjoy the place now, because we'll see who wins this fight. Red Road Commons, that's our highest residential density. What's the density there? Somebody know? How many units per acre? 57 units per acre. 1.5 to about 1.7 times background risk. They're not going to be happy if these lines go in. What's going to happen to their insurance rate?